Alright, so the fourth example is an exponential example. And the reason why I do this one kind of separate, because this is one student, for some reason, because it's kind of easy, they find it hard, alright? So it's kind of one of those catch-22 kind of things. Alright, so my function is e raised to the x squared plus y squared minus 6x plus 2y. Alright, so find your first order derivatives and set them equal to 0. So g sub x, well, it's the chain rule, so the first thing is the e term. But then you're not done yet. That's just the outside function. I've got to remember to take the derivative of the inside. And this is where it matters which variable I'm looking at. So I'm looking at the inside function, but only with respect to x. And there's only two x terms. There's the x squared and the negative 6x. So I get 2x minus 6. Set it equal to 0. Alright, g sub y. Start off exactly the same way. E to the x squared plus y squared minus 6x plus 2y. But then when I multiply by the derivative of the inside, I get a different expression because I'm taking the derivative with respect to y. Now I get 2y plus 2. Set it equal to 0. And remember, with the e term, these are never 0. And they're always positive, right? And so the only place I can actually get a 0 is why the second half is, again, remembering that chain rule is so important. The only factor I can get a 0 out of is the polynomial factor, which is the factor I get from taking the derivative of the inside. And so the 2x minus 6 can give me out a 0, and the 2y plus 2 can give me out a 0. And so as it turns out, it's actually the first case, right? I can solve 2x minus 6 equals 0 is going to give me just an x value. And the 2y plus 2 is going to give me out of just the y value. So this is, again, that case where I just solve one equation for x and one equation for y. There's no substitution. I don't have to use a matrix. It's just solve the first equation for x. And so I get x equals 3 and solve the second equation for y. And so I get y equals negative 1. And so there's one critical point at the point 3, negative 1. Which is in the domain of the function because the function has all real numbers. Alright, so that's an example of an exponential case. So we'll stop there. Next, we're going to talk about how to determine if these critical points are max, mins, or neither.